The article does not mandate a main breaker or disconnect for a lighting panel. However, it suggests that a main breaker or disconnect should be implemented for each panel board. This is done to facilitate the safe isolation of the panel board and its related circuits. This practice is commonplace and frequently mandated by local electrical codes. A main breaker or disconnect provides a convenient and secure method for conducting maintenance, troubleshooting, and emergency shutdown procedures on the panel board. This safeguard is paramount in preventing electrical hazards and ensuring the safety of personnel working on or near the electrical system. When considering the installation of a main breaker or disconnect, it's essential to consult both the National Electrical Code, or NEC, and any applicable local amendments. The NEC provides comprehensive guidelines for electrical installations, but local jurisdictions may have additional requirements that supersede or supplement the NEC. Firstly, a main breaker serves as an overcurrent protective device. It protects the panel board and its branch circuits from overloads and short circuits. If the current flowing through the panel board exceeds the rating of the main breaker, the breaker will trip, interrupting the flow of electricity and preventing damage to the equipment and wiring. Secondly, a main disconnect provides a means to completely de-energize the panel board. This is essential for safely performing maintenance or repairs on the panel board or its associated circuits. By opening the main disconnect, you can ensure that there is no voltage present in the panel board, reducing the risk of electric shock. Thirdly, the size of the main breaker or disconnect should be based on the ampacity of the panel board's busbars and the total load served by the panel board. The ampacity of the busbars is the maximum amount of current that the panel board can safely carry. The total load is the sum of the currents drawn by all of the branch circuits connected to the panel board. The main breaker or disconnect should be sized to protect the busbars from overcurrent and to handle the total load served by the panel board. When selecting a main breaker or disconnect, it's important to consider the voltage rating of the panel board. The main breaker or disconnect must have a voltage rating that is equal to or greater than the voltage rating of the panel board. For example, if the panel board has a voltage rating of 240 volts, the main breaker or disconnect must also have a voltage rating of 240 volts or higher. Additionally, the interrupting rating of the main breaker or disconnect should be considered. The interrupting rating is the maximum amount of fault current that the breaker or disconnect can safely interrupt. The interrupting rating must be high enough to handle the available fault current at the panel board's location. Available fault current calculations are crucial for determining the appropriate interrupting rating. These calculations take into account the impedance of the utility transformer, the service conductors, and other factors that can affect the amount of fault current that can flow in the event of a short circuit. In addition to the NEC and local codes, other standards may apply to the installation of lighting panels and their associated main breakers or disconnects. These standards may include Underwriters Laboratories, or ALL standards, Institute of Electrical and Electronics Engineers, or IEE standards, and National Electrical Manufacturers Association, or NEMA standards. UL standards provide requirements for the safety of electrical equipment. IEE standards provide guidance on the design and operation of electrical systems. NEMA standards provide requirements for the performance and construction of electrical equipment. When installing a lighting panel and its associated main breaker or disconnect, it's essential to follow all applicable codes and standards. This will help to ensure the safety of the installation and the reliable operation of the electrical system. Furthermore, proper grounding and bonding are critical for the safe operation of a lighting panel. Grounding provides a low impedance path for fault current to return to the source, which helps to trip over current protective devices and prevent electric shock. Bonding ensures that all metal parts of the electrical system are electrically connected, which also helps to prevent electric shock. Grounding and bonding should be performed in accordance with the NEC and any applicable local codes. In summary, while the referenced article doesn't explicitly mandate a main breaker or disconnect for lighting panels, it strongly recommends their use for safety and maintenance purposes. The decision to install a main breaker or disconnect should be based on a thorough assessment of the specific application, considering factors such as local codes, available fault current, and the need for safe isolation and maintenance. Always consult with a qualified electrician to ensure that the installation is performed in accordance with all applicable codes and standards. Regular inspection and maintenance of lighting panels and their associated components are also essential for ensuring the continued safe and reliable operation of the electrical system. This includes checking for loose connections, damaged wiring, and signs of overheating. Over time, connections can loosen due to vibration or thermal cycling. Damaged wiring can occur due to physical stress or environmental factors. Overheating can be caused by loose connections, overloaded circuits, or other problems. Any problems that are detected during inspection should be addressed promptly to prevent potential hazards. For example, loose connections should be tightened, damaged wiring should be repaired or replaced, and overloaded circuits should be corrected. In addition to visual inspections, electrical testing should also be performed on a regular basis to ensure that the lighting panel and its associated components are functioning properly. This testing may include insulation resistance testing, continuity testing, and voltage and current measurements. Insulation resistance testing measures the resistance of the insulation surrounding the conductors. This test can help to identify insulation breakdown, which can lead to ground faults. Continuity testing verifies that there is a continuous electrical path between 2 points. This test can help to identify open circuits. Voltage and current measurements can be used to verify that the lighting panel is operating within its rated parameters. All testing should be performed by qualified personnel using appropriate test equipment. The results of the testing should be documented and used to identify any potential problems. It's also important to keep accurate records of all maintenance and repairs performed on the lighting panel. These records can be used to track the performance of the lighting panel over time and to identify any recurring problems. Good record keeping is essential for ensuring the long-term reliability and safety of the electrical system. Furthermore, consider the environment in which the lighting panel is installed. If the lighting panel is installed in a harsh environment, such as a damp or corrosive location, additional measures may be necessary to protect the panel from damage. For example, the panel may need to be installed in a weatherproof enclosure or coated with a corrosion-resistant material. The type of enclosure or coating should be selected based on the specific environmental conditions. In addition, surge protection may be necessary to protect the lighting panel from voltage surges caused by lightning or other events. Voltage surges can damage sensitive electronic equipment and can also create a fire hazard. Surge protective devices, or SPDs, can be installed to divert surge current away from the lighting panel and protect it from damage. The selection of an appropriate SPD should be based on the anticipated surge current levels and the sensitivity of the equipment being protected. Training is also a critical aspect of ensuring the safe and reliable operation of lighting panels. All personnel who work on or near lighting panels should be properly trained in electrical safety procedures. This training should include topics such as lockout/tagout procedures, personal protective equipment, or PPE, and the hazards of electricity. Lockout/tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. PPE is used to protect workers from electrical hazards such as electric shock and arc flash. By providing adequate training, employers can help to ensure that their employees are able to work safely around electricity. Another important consideration is the use of arc flash protection. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates an explosive release of energy. Arc flash can cause serious burns, blindness, and even death. Arc flash protection is designed to mitigate the hazards of arc flash. This protection may include the use of arc-resistant switchgear, remote racking systems, and PPE. The selection of appropriate arc flash protection should be based on an arc flash hazard analysis. This analysis assesses the potential arc flash hazards in a particular location and recommends appropriate protective measures. The NEC includes requirements for arc flash hazard analysis and arc flash protection. Specifically, NEC Section 110.16 requires that electrical equipment be marked with a warning label indicating the potential arc flash hazards. This label must include information such as the incident energy level, the working distance, and the required PPE. Finally, it's important to stay up to date on the latest codes and standards related to lighting panels. The NEC is updated every 3 years, and local codes may also be updated periodically. By staying informed of the latest requirements, you can ensure that your lighting panel installations are safe and compliant. Consider subscribing to industry publications and attending training courses to stay abreast of the latest developments. In addition to the above considerations, it's also important to consider the impact of lighting panel design on energy efficiency. Lighting can account for a significant portion of a building's energy consumption. By selecting energy-efficient lighting fixtures and controls, you can reduce energy costs and improve the overall sustainability of the building. Energy-efficient lighting fixtures include light-emitting diodes, or LEDs, compact fluorescent lamps, or CFLs, and high-intensity discharge, or HID, lamps. Lighting controls include occupancy sensors, daylight sensors, and dimming systems. These controls can be used to automatically turn off or dim lights when they are not needed. When designing a lighting system, it's important to consider the specific needs of the occupants and the tasks that will be performed in the space. The lighting level should be appropriate for the tasks being performed, and the lighting should be uniform and glare-free. A well-designed lighting system can improve productivity, reduce eye strain, and enhance the overall comfort of the space. Also, consider the use of renewable energy sources to power lighting panels. Solar power is a clean and sustainable energy source that can be used to power lighting systems. Solar panels can be installed on the roof of a building to generate electricity, which can then be used to power lighting panels. The use of solar power can reduce reliance on fossil fuels and lower energy costs. The size of the solar panel system should be based on the energy consumption of the lighting system and the amount of sunlight available at the location. Incentives and rebates may be available from government agencies and utility companies to help offset the cost of installing solar panels. Furthermore, smart lighting systems can be used to optimize energy efficiency and improve lighting quality. Smart lighting systems use sensors, controls, and software to automatically adjust lighting levels based on occupancy, daylight, and other factors. These systems can also be used to monitor energy consumption and identify opportunities for further energy savings. Smart lighting systems can be integrated with other building systems such as heating, ventilation, and air conditioning, or HVAC, to create a more energy efficient and comfortable environment. Another important aspect of lighting panel design is the selection of appropriate wiring methods. The wiring method should be selected based on the type of conductors, the ampacity of the conductors, and the environmental conditions. Common wiring methods include conduit, cable tray, and direct burial. Conduit is a rigid or flexible tube that protects conductors from damage. Cable tray is a metal structure that supports conductors and cables. Direct burial is a method of burying conductors directly in the ground. The NEC specifies the allowable wiring methods for different applications. When selecting a wiring method, it's important to consider the cost, the ease of installation, and the durability of the wiring method. Finally, documentation is essential for the safe and reliable operation of lighting panels. Accurate and up-to-date documentation should be maintained for all lighting panel installations. This documentation should include wiring diagrams, panel schedules, and equipment specifications. Wiring diagrams show the connections between the different components of the lighting panel. Panel schedules list the circuits served by the lighting panel and the loads connected to each circuit. Equipment specifications provide detailed information about the lighting panel and its associated components. This documentation should be readily available to qualified personnel who are responsible for maintaining and repairing the lighting panel. The location of the main breaker or disconnect should be clearly marked in the lighting panel. The marking should be durable and easy to read. This will help to ensure that the main breaker or disconnect can be quickly located in an emergency. The marking should also indicate the voltage and current rating of the main breaker or disconnect. In addition to the above considerations, it's also important to consider the aesthetics of the lighting panel. The lighting panel should be installed in a location where it is not obtrusive and does not detract from the appearance of the space. The lighting panel should also be clean and well maintained. A well-maintained lighting panel will not only look better but will also be more likely to operate safely and reliably. Consider using a recessed lighting panel to minimize its visibility. A recessed lighting panel is installed inside a wall or ceiling so it is not visible from the outside. This can help to create a cleaner and more streamlined look. The location of the lighting panel should be chosen carefully to minimize its impact on the aesthetics of the space. The color of the lighting panel should also be chosen to blend in with the surrounding decor.